Hello students, my name is Rupali Chaure and I am Assistant Professor in CSE Department of SRT College. Today we are going to discuss a very important topic of programming in C, which is pointers, and in my previous video I already discussed what is a pointer and how to declare it. In this video we will discuss about some examples of pointers and how to use the pointer variables. So what actually pointer is? Pointer can be declared by using asterisk sign. So pointer variables must be declared before we use them, and the general form is given here. We have to give the data type of the pointer, and with asterisk sign we give the pointer name. Three things are very much specified in the above declaration. The first one is the asterisk sign, which tells us that the variable pointer name is a pointer variable. It means that the pointer name which is declared after asterisk sign, it is the name of the pointer variable. Second thing which is very obvious about this declaration, it is that the pointer name also needs a memory location. It means the variable which we are defining as a pointer variable, it also needs some memory location to be stored. And the third point, which is very obvious, is that the pointer name points to a variable of type data type. What does it mean? It means that the pointer variable pointer name which we have declared here can only point to the type of variable which is defined here as a data type. We will understand these things in our next slides. For example, I am declaring here a pointer variable count with the asterisk sign. Now the data type for this pointer variable is integer. So what does it mean? It means that the count pointer variable can only point to a variable whose data type is integer. Similarly, the next pointer variable which I am using here is speed, and this speed pointer variable is of data type float. So which type of address it will store? The speed pointer variable will store the memory address of a floating point of variable. Okay, so once a pointer variable has been declared, after that we use assignment statement to assign the address, to load the address or to store the address into that pointer variable. As shown here, we can see here that I have declared a pointer variable p with this asterisk sign whose data type is integer, and an integer variable which is xyz and its data type is also integer. Now I will initialize this pointer variable p with this statement, and I am storing the address of this pointer, this integer type variable xyz into the pointer variable p. As we all know that ampersand here, which I am using in this statement, the ampersand sign gives the address of this variable. So the address of this integer variable xyz will be stored in this pointer variable. Why we are able to store the address in this variable p? Because it is declared as a pointer variable. Okay, so declaring the data type of pointer variable, and after that we assign the address, which is called the initialization of this pointer variable. Now there are some important things in the use of ampersand and asterisk. Let's discuss it. Pointer variables must always point to a data item of the same type. Means if we are declaring a pointer variable of data type integer, it means that this p variable can only store the address of a variable whose data type is integer. So here in this sample code I have written here that x is a float variable and p is a pointer variable whose data type is integer. So if I am using this statement, assignment statement, where this floating type of variable address is going to be stored in this pointer variable, then this will be generating error. So this will result in erroneous output because the data type of this x does not match to the data type of this pointer variable. So this is very obvious that we have to declare the pointer variable with the same data type whose address we want to store in it. Okay, so and the second most important thing here is assigning an absolute address to a pointer variable is prohibited. Means we cannot store any constant value to the pointer variable. Okay, we have to give any address in this pointer variable through some variable name only. We cannot use any constant value like this. So these two things are very important while using pointers, initializing the pointers. This is the next slide in which we will learn how to access the variables through its pointer. Now once the pointer has been assigned the address of variable, the value of the variable can be accessed using the indirection operator asterisk. Now after the declaration of pointer variable, when in the assignment statement we use the asterisk, then that operator is called indirection. In the data type declaration, variable declaration block, if we use asterisk, then it is a pointer variables notation. But if in further program in some assignment statement we use the asterisk sign, then it is called indirection operator. What does it mean? It means that we will understand this by the sample code. We have declared two integer variables here, a and b, and one pointer variable p of integer data type. Now in first statement I am assigning the address of a to this p, and if I want to copy this value of a to b, then what will I do? I will write it like that, b equal to asterisk p. It means asterisk p will give the value which is stored at memory location a. Okay, so in the first statement we are assigning the address of a to the p. So p is now pointing to the variable a, and to access the value of this value which is stored in this location, we will use asterisk p. So asterisk p gives the data value which is stored at this memory location. It means the memory location a. So this code is equivalent to b equal to a, means we are storing the value of a variable to the b, but not directly writing like this. We are copying the value of a from the memory location a. Okay, so this is our first example in which we are declaring these four types of variables: integer variable a, float variable b, c, and double d. Character type of variable is ch. We are initializing some values in these variable. A is integer, so we are giving it 10. B is 2.5, which is a float variable. C is also float, so we are initializing it with 12.36. Now d is a double variable, so we are giving this value to the d, and a character variable a, capital A, is stored in the ch variable. Now let us see what these statements will give the output. So the first printf statement, where I am using %d as a format specifier, will show the value of a. This the first variable here. So a is stored, I will read it like this: a is stored in location, %u will be replaced by the address here, address of a. So to display address of any memory location, I will use the format specifier %u. So this first printf statement will print the value of a, then the value of address of variable a. Similarly, in second statement for variable b, we will print the value and then its address. So what this program is doing, the statements here, printf statements here, are printing the variable's value and its memory location. Okay, so let's see what is the output. Output will be displayed like this. This is for variable a. So 10 is the value and its memory location is this. 2.5 is the value and the memory location will be like this. Next for C, then for D, and then for CH, character type of variable A, which is stored on this memory location. So these are the memory location which are printed along with the values which are stored on that location. Now incidentally, variables A, B, C, D and CH are allocated to continuous memory location. This is not always possible, but coincidentally this is in the case of our example. Okay, so let us move to our second example. What is this? The second example shows the pointer arithmetic, in which we have declared two integer variables a and b, another integer variable with the initialized value 5 c, and a pointer variable p which is of data type integer. So here I am calculating the value of a with this formula 4 multiplied by c into c plus 5, and now I am storing the address of C to the pointer variable P. So asterisk P here will point to the value of C, which we learned in the previous slide. So what asterisk C now is used as an indirection operator. So asterisk P will give the value stored at the memory location, which is stored in the pointer variable P. So P contains the memory location of C, and the data value contained at C will be used here in the operation. This is the multiplication operation. So B's value will be calculated with the value of C directly read from the memory location with the help of pointer variable P. Okay, so these both statements are equivalent. By this program, I want to show that whether I use direct variable here C, or I use the indirection operator like this, pointer of P, and P stores the address of C. So both will result in the same calculation by this printf statement. Okay. And next move to our third example. In this third example, we are understanding the different formats of ampersand and pointer asterisk signs with the variables. So here let us discuss what's the program. We are using two integer variables xy, one pointer variable ptr, initializing the values here. X is equal to 10 and the address of x is stored in the ptr variable. Now the asterisk ptr is stored in the y. What does it mean? What will this value give? Asterisk ptr. Asterisk ptr means the value which is stored on the memory location pointed by the ptr variable. It means that the memory location of x stores the value 10. So ultimately y will also store value 10. Okay. Now what does this printf statement displaying? Percentage d is stored in location %u/n. So first %d will be replaced by this value x, and second %u will be replaced by this address. So x, the value of x is 10 and the address will be printed here. Second, asterisk of ampersand of x. What does it mean? Asterisk of ampersand of x, which is double in direction. Ampersand of x means the address of the variable x and the value stored at that location. Okay, so let us see what does it give as an output. Same value 10 stored in location this. Here we are using these addresses or reference in this case of our program. The next statement, next third printf statement is, sorry, okay, so thank you very much. Stay tuned and keep learning.